Okay, so we're gonna continue with part two. This is the same probability and statistic. I put up part one, and this is a continuation of that. So we're going to take a look at another common example that we use in teaching probability. Okay, and so in statistic, of course, so you need to understand probability. This is just rolling a single die. This is a die. It has 6 faces and it has 6 numbers, and each number on each face. So rolling a single die usually produces a uniform distribution. With of course each number having an equal probability of 1 by 6, because you have the total possible outcome 6, and you have each surface with one number on each surface is going to give you 1 out of 6 possibilities. So if you want to get 5, so the probability of getting a 5 out of a die, rolling a die, is 1 by 6. Okay, the same for every number on that die. And you have only 6 number anyway, 1, 2, 3, 4, 5, 6. So you have an equal probability of getting 1, rolling a single die, getting a 2, rolling a single die, getting a 3, rolling a single die, getting 4, 5, 6, rolling a single die. They would have only 1 by 6. Okay. So 1 by 6, you can go to your Excel. Now I put part 2 here so you can find easily. So 1 divided by 6, yes, is going to give you that. And then of course you multiply this with this, and 100 is going to give you your percent. I'm going to write this down for you, percentage. But of course you should be able to know that by now. I'm not going to put age on it, just percentage. So you have about 16.66 percent. So that rolling a die, I'm just going to write a die example here. So getting a number out of that die, which is 6. We have many different dies. This is a 6 phases die. So I wrote a probability of getting a number, and that number can be 1 or 6. So num is going to be 1 to 6, any number. And if you, of course, roll multiple dice, just like we did the like your last example is a coin, and of course a multiple coins. So if you have like a multiple dice, not just a single die, you're gonna have a bell shape, normal distribution again. So with the most frequent outcomes being in the middle. So like a sum of 14, when rolling 4 dice like that. So anyway, so let's go into details, one by one here. So when you look at the die, I've already told you this is just a regular, 6 faces, a standard die, and we have many different dies, many different dies nowadays. You have like 8 phases, 20 phases even. Depends on the game that you're playing. So anyways, a standard die has 6 phases, and each number from 1 all the way to 6. So we have 1, 2, 3, 4, 5, 6, and 1 number on each face. And when you roll that die, there are 6 possible outcomes. 1, 2, 3, 4, 5, and 6. So these are the possible outcomes. The total possible outcomes are 6. So each outcome is equally likely because the die is fair. Because you have each number on each surface on that die, and your die is fair. So each number is going to come out, and the likelihood of each number coming out is completely fair, completely equally likely. And so the probability of rolling any particular number, like 1, okay, the probability of getting a 1 or getting a 2 or 3 or 4 or 5 or 6, okay, is 1 by 6, because you have 6 possible outcomes and you're looking at 1 out of that. So if we go back to the bin example, you have a 6 total inside of the bin, and you're taking 1 out of it, like that. So 1 by 6, I have already shown you there's an XO right here, and that is a 16.67%. Okay. Of course, this is your bar, right? Bar graph. it's going to show you that each number from 1 to 6 has the same probability, but they have the same height here. You know, see these orange bars. It's showing you they have the same probability. So just by looking at the bar, you can be able to say, oh, the probability of getting this is the same as the probability of getting that, you know, creating a uniform distribution. So in this distribution, all outcomes have the same probability. So the graph, you know, when you look at it carefully, has equally tall bars right here, you know. Okay, meaning like they have the same height. The uniform distribution, you know. So if you think about the uniform distribution means that every possible outcome in this case, rolling a 1, 2, 3, 4, 5, 6 has the same chance of happening. Okay, and this is different from a normal bell-shaped distribution where some outcomes are more likely than others. So what is the difference between this uniform distribution and your normal bell-shaped distribution? So for normal bell-shaped distribution, you know that some of the outcomes are more likely than other because they have different heights. Here you have equal heights, so therefore it is called a uniform distribution. Now rolling multiple die. Okay, so if you have like a multiple dice and you're gonna roll them, so it's going to tell you what happens when you roll. Let's say in this example we have 4, we have 4 dice. So if you roll 4 dice, what is going to happen? So you got to think about rolling multiple dice creates more possible outcomes because one die gives you 6. So if you roll 4, you have more possible outcomes. So altogether, you have 21 possible sums, ranging from 4 to 24. Pay attention, when you get to here, I remember in the past a student asked like, oh, why are we having 21 possible outcomes, so why is it not 24? So they're calculating like 6 fixes here and 4 dice, so 6 times 4 is 24. It doesn't work like that, okay, because of the so when you're rolling the 4 dice, you're looking at 4 surfaces, okay, so you're looking at 4 faces, like in the coin example, you roll the 2 coins and you look at the first coin. Okay, what you have is a head or tail, and then let me go back here. So you're doing exactly this. All right. So let me put this a little bit on this side so you can be able to see it. So anyway, so this is exactly what you're doing, and then so in our case right now, let me write this down. So you're gonna have like the first die, and then the second die, and then the third die, and then the fourth die, and then of course you're gonna list out all of your event here, your outcomes, here for you. So the very first one it can happen is you're gonna get 1 on each. Okay, what am I writing here? So let's say this is a 1, one, it turn up all ones, and then it's gonna turn up UK 2, and then of course all 1 here, so that's exactly what you have to do. Okay, and then you're gonna have like a 1 1 here, so this is event 2 and then event 3. So anyway, so etc, you do that, and in all possible combination, you're gonna have only 21. So this is what it is talking about. So when we talk about 21 possible outcomes, we're referring to the sum of the numbers rolled on 4 dice. Okay, so let me go back here. Here, so let me go back here, and you're gonna see like the first row, second row, and that's event 1, 2, 3, and it is showing you, okay, on the die. I'm just gonna write down that this is your die, okay, your first die, and you should read it on this way. I should make a little yellow here for you. So anyway, so this is your die number 1, 2, 3, okay, and then the fourth die. And this is what we're talking about. Yes, so if we go back here, 21 possible outcomes, don't think so much on it. Yes, we're talking about 21 possible outcomes. We're talking about the sum of the numbers rolled on 4 dice, not the total number of different combinations of rolls. because combinational rules mean if you're thinking about like 6 phases for each die, then if you're rolling 4 dice, the total number of possible combinations, yeah, is going to be 6 phases to the power 4, 1296 combination you're gonna get. So what I did, I put okay to clarify. Oh, because I remember one of the students asked me about this 21 possible outcomes and he can't see. Okay, yeah, the difference between the possible outcomes like this. Okay, so when it comes to 4 dice, it's better that I go back here and show you. Okay, you have to list it like this. Okay, so you go like 1, 2, 3, so you can be able to see it. But in this example, I'm gonna go to that side a little bit. Okay, so in this example, this 21, right, the possible outcomes is actually the sum, yeah? And I think they failed to write that down for the clarification of it. So the sum of your 4 dice, okay? This is what we're talking about. So here is going to give you 4, yeah, equal to 4. This one, if you add it 1, 2, 3, and then 4, 5, okay? This is going to give you 5 right here. So let me go to this side so you can see it, yeah? So and so on. So of course this is going to give you 6, okay? And then if you continue to write etc, okay, etc, I can write a sum for you because you will have to write a 1200 and 1206 to the power 4 is going to give you calculate 1296. Okay, so the total, okay, event is, I'm just gonna write it here around here, etc, okay, will give you 1296. So this one comes from, you have, right, a 6, right, a 6 possible outcome per dice, and you have 4 of them. See, I always do the exponent 4, and that's going to give you 1296. Okay, so I could write this down like this way so you can be able to see, you know, and this one equal to that. Okay, 1296. Okay, combination of that. But when we say 21 possible outcome like that, I am gonna modify, you know, whoever wrote this, I don't know who. Okay, so we have 21 possible outcomes. So the most likely outcome is the value 14, meaning like the 24 possible outcome when you add up the numbers on the 4 dice. Okay, and that is all you can get. Of course, if I go down to like getting a number 6, yeah, so getting a number 6, event 4 right here, yeah, you have this way and also you have another way, yeah, and that is I can write like it backwards like this. Okay, so you can be able to see like getting a 6, okay, it's gonna be like this, yeah. And then of course getting a 7 is gonna be also different, yeah. We go like 111, and then we're doing the same thing, yeah, 3, and then now the event 5, it can be 4 like this. Okay, and there's another way to get 7 as well, yeah, and that is going to be 1 and then 1, and then of course 2 and then 3, and that is your event 6, yeah. Event 7 is going to give you the sum of 7 again, yeah, and that one is going to be let me do it 2, 2, and then 2 and 2 is going to give you 7 as well. See like how these combinations, they start to create, you know how like the I'm just gonna highlight this for you so you can be able to see very, very clearly, yeah. So making a 7 the sum is going to be different here to give it a little bit of a different color so you can see that. See that? Now you can clearly see the sum of getting 6 is you have 2, yeah, possible outcomes, 2 events. The sum of getting 7, you have 3 events. So and so for 8 you're gonna get 3, for 9 you're gonna get 3. So I am going to quickly write this down for you, yeah. So getting 4, getting 5, getting 6, getting 7. I'm gonna go to this side. Okay, so why do we have 24 like that is getting some, All right, this is sum from all this combination. These are all the combination event. Getting 4 is only one time. Yeah, getting 4 is a single time, and then getting 5 is a single time, and this is time. And getting 6 is 2 times. Yeah, and then of course getting 7 is three times. Okay. Getting 8 is also 3 times. Okay. Then of course getting 9 is going to be 3 times. Don't do like I do in my brain. Okay, you can all write it down. So I've done this as 1,000 times. So therefore, yeah, it's in my head. Yeah, and of course, 10 is going to be 3 times. 11 is going to give you 3 times. Yeah, and 12 is going to give you like 3 times. Okay, and 13 is going to give you 3 times. Okay, then 14 is going to give you another 3 times. Yeah? And then 15 is going to give you another 3 times. Then 16 is going to give you 3 times. And then of course 17 it's going to give you 3 times. And then 18, so 7 going to give you 2, I guess. Yes, 2. Yeah? And then 19 is 2. And then 20 is 2. Yeah? And 21 1, I believe, yes. And 22 is 1. And then 23 is 1. And then 24, getting 24 is also 1. Okay, so when you count it, look, yeah, so I'm just gonna go ahead and count, which is a sum, of course. If you count it, or I should say not sum, count. Okay, so if you count this from here to here, see, and that is what we're talking about. Yeah, so I'm just gonna go ahead and make it a little pink right here, and this is the possible outcome we're talking about. Okay, and that is the 21 possible outcomes. Okay. How do I do the arrow? It's not giving me the arrow. All right. Oh my gosh. Well, probably I can do the arrow, I guess. Okay, definitely I can do the arrow. So I can just go ahead and do an insert on some shape here. So probably there's an arrow. Yep. So anyways, this is what we're talking about. Yep. And this guy right there. Yeah. So don't be confused. Don't be confused about it. So for clarification purposes, okay, so I sum it up here. Yeah. So if I sum it up here, this is just a sum of how many, the total for each. If you add the numbers on the surfaces that show up on your 4 dies, you have 21 possible outcomes. Yeah. And that you will get 7 in sum by adding the 4 numbers here appear on your 4 dice. You can get 3 different variations. Yeah, this is just variations of how to add these numbers. So anyway, but this 1,296, all right, that number is a different thing. So I'm going to make a little blue color here for you. Okay, so 1,296 is a different thing, and that is why we write it down just like we did, okay, in the previous example, like that. Okay, so this is when you have like let me make a color here. So when you have a, okay, two, right? Two surfaces, your head and tail, and then you have two coins that you are throwing, yeah? So at that time, you're gonna have a four. See, 1, 2, 3, 4, okay, event that can happen, okay? And this is what we call sum, yeah? Summing like h plus h, so you have 2h, okay? I should write down. So we're talking about sum. That you're gonna have I should write this is 2t here. I made a mistake here. This is supposed to be, you're getting one head and one tail here, yeah? So this is saying like getting a two head only one time, getting a two tail only one time, and getting head and tail is 2 times, yeah? So you have some possible outcome is only 1 to 3 here, yeah? Of course, you have two variations for getting head and tail, which is this guy, yeah? And that's how we write for this. Huh? So when we say possible outcomes, we're doing this, okay, sum of getting it. And I think that's what a lot of the students don't understand. Yeah, this I should say like 2 coins, okay. Okay, so make sure watch this again and again so you kind of get that. So when we say possible outcomes, don't try to get the possible all combinations here. Yeah, this is combinations of the event that can happen. This is a possible outcomes that you can ever get if you sum it up. Yeah, sum up this stuff in there. Okay, all right. So anyway, so let's go back to here, and I have already explained about this little one phrase right here. Again, I'll confuse you a great deal, yeah? Okay, so let's go to the next. Of course, the ending or the most likely outcome is the value 14, and that is because if you look at it, see, like we started out 1, we ended up 1, right? So if we do the histogram here, you're gonna get 1 over here and then go up to 3 here. So you have 1, and then you have, let's say like if I start to shape it like that, yeah, you're gonna see. So let's start giving a little yeah, maybe purple, yeah? So if I start to shape, yeah, that means a 1. Of course, this is also another, yeah, purple here, and then we're gonna have this one mean 2, yeah? So I have 2 on this side, yeah? I can just go and quickly do this. And then of course this one is 3, yeah? See that, yeah? And then this one is 3, yeah? So this is what we're talking about, how we can be able to, you know, quickly, you know, like see the histogram. And of course you also have like a histogram for 2 here, yeah? So if you draw like that, you can see clearly, yeah, how the bell shape is around 14, yes? So now I'm just going to give 1 each here, yeah, for you. See that? So this is where your bell shape curve is. Okay, I think you can see this clearly, yeah, on your, because I don't need this one, where just go back here and just give no fill on that. So anyway, so this is what we're talking about. So the 14, yeah, right here is gonna give a little gray color here, yeah, and that's what it's talking about, yeah. So when you add up the numbers on the 4 dice, the most likely outcome is the value 14. Okay, so that's kind of like your histogram pattern going up like this way. Okay, So anyways, I draw a draft sketch right here for you. So anyway, this is how you see a little curve, right? Bell-shaped curve, because my shape is not very good. But anyway, you got the idea of what you're looking at, and that's what we're talking about this 14 here. Yeah, so the most likely outcome is going to be 14. So I believe that now you can be able to understand, yeah, what is going on, and do not confuse, because just one single line, but if your brain gotta be seeing all of this, okay? Otherwise, yeah, it would be very difficult. That's why many students, I'm not getting it, I don't know what's going on. It's because you're missing out on the combination advances, okay? 1296. Your sum, if you add these things, this is everything that we can get at 21. Yeah, and if you draw it, the most likely outcome is getting a sum of these numbers on the 4 dice is 14. Okay, so let's get back to here. So now you know, although you have like a 1296 different combinations, you know, of dice rolls, the possible sums range from 4 to 24. 4, okay, starting from 4 to 24. And so which is going to give you 21 distinct sums, which is this guy, yeah, 21 distinct sums right there. And not all sums are equally likely, and the distribution of sums forms a bell shape, which I have already shown you. It forms a bell shape like this, okay, and with sums, of course, near the middle, which is 14, yeah, being the most likely. Alright, so we're done with this, so let's move on to the next one. Now we're gonna do 2 dice instead of 4, yeah, so probability of values when rolling 2 dice. So the first thing, we gotta do exactly the same as we always do, yeah, so rolling 2 dice is the sum of 2 separate random processes, yeah, this is where the sum comes from. So here, yeah, we don't really write it down here at that, because it's all common sense, yeah, so when we talk about it, it's a common sense, so I gotta write that back down for you here, because if you cannot be able to get that common sense, you have no idea what you're doing, you know. So we're gonna do the same thing, and I am going to go down probably around here, yeah. So now we are going to do exactly the same, yeah, but this time your die is going to be just 2, yeah. So I'm just gonna write it here. So you have your die 1 and then die 2, yeah, and then of course your event is here, yeah, your event 1, your event 2, you can get 1 1, yeah, you can get 1 2 and 1, yes, and of course we start to look at the sum, yeah, on this row right there for you. So you're gonna get a 2 here, yeah, and then you're gonna get 3 here. Of course you can get a variation like this, yeah, to get 3 as well, yeah. So you can see like we're doing exact, yeah, same thing like this. And then of course you can come back here and sum getting, yeah, we can do the same here for that, so you can clearly see this, yes. So we start with 2 and then 3, you see that? So this is what we do, yeah. Okay, so I quickly draw this for you, yeah. So you have a 2 die here, and the first thing you do is each die has 6, yeah, faces, and so and then you put to the power 2 dice, and it's going to give you 36. And this is what we're talking about here, okay, 36. Yeah, see the 36. And there are 36 possible outcomes. And of course, for the sum, yeah, the result can be any value from 2 to 12, yeah, and which is going to be this. Yeah, so here this is some possible outcome, this is a combination. Yeah, sometimes the wording, possible outcomes for the combination, which is actually event, because sometimes the event we call it outcomes anyway. So you have an issue understanding the sum possible outcomes and the combination possible outcomes. Yeah, you will definitely get into confusion right in there. So this is a separate thing, which is we list the events, all of the possible outcomes or possible events that can happen is 36. And this is a sum getting, if you add this two, okay, you can get two. If you add this two, okay, phases that show up, then you can get three, okay, two times, two one times, four three times. So that's what we call it possible outcome. So that's 11 here. So from 2 all the way to 12 you can get. And of course, if you add them up, then you can get 36. Yeah. So and these are what we're writing here. Yeah. So of course, you show all of this. Okay. We have 1 1 1 2, and that is exactly the same as what I am writing here. Yeah. 1 2 1 1 2 1 3 2 2 3 1, and you have 36. Okay. Of them. And when you, of course, actually draw the curve, or you will get a normal distribution. My curve is not very perfect, but you should see this as a bell, right? Bell-shaped curve, and your mean is around here, which is 6. Which is actually 6 mean. Like you can get, you can list 6 different variation for getting 7. Adding getting 7 for the sum. And that is what we're writing here. So there are 36 possible outcomes. That is actually on the combination side. This time he is emphasizing on this side. Okay, and then the result can be any value from 2 to 12 inclusively, which is this one from 2 to 12 inclusively. If you count it, you have about 11 possible outcomes right in there. And however, the probability of the possible outcomes are not all equal as they were with one dice. Okay, meaning like the probability that you're getting are not equal. See, you have 1 here, 2 3 4 5, and then you have a 6. Okay, for it. Okay. I must put this as a different color, which is a different color like this. My Instagram is, and I should put this in a different color. So when I copy it, it went into the wrong color. Okay, this is better. So now you can be able to see it very clearly. See that? So therefore the probability, that's 6 and that's 5. And out of 36. And this one is a 5 out of 36, so they're not the same. Also here, the probability, if you want to calculate it, 1 out of 47, 3 out of 47. If you don't want to do the entire 1296 events right in there. And that's basically, I think, all the things that confuse you. Okay, what you have to do is write like this, like I do. It doesn't take a long time. Less than about 5 minutes to do it, and you can, in your brain, you can be able to clearly understand that. Okay, and so let me go back to this. Okay, and so that's exactly what we do. Some people draw very elaborately like this. I just go and write in my Excel like this. Okay? This is what I write. I don't really write very elaborately like this, but it's the same thing. When you look at it, see like how, and in fact I understand the way I draw, more than reading this. So anyway, so there's only one way to get to. Why? Because look at this. Go back to what I just wrote it. There is only one single way to get to. Because you cannot get any other way, than this. See how easy. And there are 2 ways to get 3. See that? And there are 3 ways to get 4. Okay, so what is so difficult about it? It isn't. There are 4 ways to get 5, 5 ways to get 6, 6 ways to get 7, 5 ways to get 8, 4 ways to get 9, 3 ways to get 10, and 2 ways to get 11, and 1 way to get 12. Okay, 12 means like 6, 6 show up here and 6 show up here, and you add it and you got 12. Why do we have to add it? That's a common sense. Every time you throw the die, what we do is we add them. When you go to casino or whatever, you play dice, and when you roll it, what you do is you add the sum. That's exactly what we do. So these common sense, we don't have to tell you about it, but that's what you do when you play or roll the dice. And that's what it's writing. 6 way to get a 7. 7. So 6 way out of 36 is going to give you 0.16. Getting 2, there's only 1 way. So 1 out of 36, your probability of getting a sum of 2 is 0.0278 times 100 is going to give you 2.78%. This one is 16.67% getting 7. So therefore the probability of getting a 7 is higher than any other value. So if you want to calculate the probability, all you have to do is I'm just gonna write down the probability. Probability. So if you want to calculate the probability, all you have to do is just calculate when divided by this guy and then times 100. Yes, and that's gonna give you the probability. So I'm just gonna make it 2 decimals is easier for you to look at it. So that's a 2.78%. So I already transferred that into percentage from decimal. Okay, so now I calculated. Okay, I try to save time so it won't take the video is going to be so long. So anyways, I calculate this one for you. So when you take a look at it, you can see the percent of it. So getting a 1, so 1 divided by 36. So if you want to know like what I do, okay, in your Excel, some people got so all you do is give that cell divided by this log cell. So you do your $sign and then this cell $sign. That's going to give you and then pull it down. Yes. I think I should show you if you forget about how to calculate. Okay, all you have to do is do like this, and then I forgot the bracket. So this give that, okay, divided by, yes, and you're gonna have this cell, yes, and then of course make sure you can lock this cell. If you want to lock it, you can lock it like this way, yes, and then of course after you do, you can change that decimal into a percentage. Okay, so then all you have to do is just pull it down. So it will give you these calculation. If you don't believe me, you can just delete everything here like that. And after you have programmed this Excel, you can quickly draw like this. You don't have to do, this is going to give you a perfect calculation for you guys. You only have to program one cell and drag down, and it will give you, okay? So it calculates all of the percentages, and you see this guy, look at that, so I'm just going to go ahead and highlight this again for you. So you can see that the highest probability, it's at 7. And if you want to just do with a visual, I usually just go straight to histogram, so I don't even have to calculate the whole thing. So you can be able to see this. Okay, all right, so anyway, so that's how we calculate, that's how we calculate the mean, standard deviation, okay, and then of course all probability of the possible outcomes. And do not forget the possible outcomes, you have combinations, and you also have the sum of that. So why are we summing up? Because it is a common sense, because your event is rolling the 2 dice. So every time we roll the 2 dice, we sum it up to get the total number that show up. Otherwise, what are you going to do? There's nothing to do with what that 2 dice for. So anyways, don't forget the common sense that you need to understand to incorporate most of the probability problems, and you're gonna be okay, I guess, so that way. So anyways, so several dice, so you got 1 here, and you have 2 here, you have 3 here, and then you have 4 here. So now you should be able to read the histogram, and you should be able to where these histograms come from, like this. Okay, I've just calculated a 2 example for you, and that's what you should be doing and when you're studying, yeah. So how long it takes, yeah, to study this. If you're just reading, you will never get it. Okay, you have to read and you have to actually follow by doing this. Okay, and that is what we say one lecture. Okay, 1 hour lecture is equal to about 3 hours of your effort, okay, at your home. So doing what? Doing this, okay, doing calculation like that. Otherwise, you will not clearly get any of the stuff you're reading. You will be always confused. Yeah, the favorite word of the student. I'm confused. I'm confused. There's nothing to be confused about if you clear it everything, yeah, by calculating it. So anyway, so that this is your 1 die and that's your 2 dies, and then this is your 3 dies and that's your 4 dies. And you know how to read. This is an equal distribution. We normal distribution started with the highest probability. You can see all the probability right here. Yeah, and when you look at it, this is going to go from 2 all the way to 12. All right, and what you can be able to do is you can count them out. Yeah, so if you count it, you have 11, and the variation, you can see it, yeah, directly from the histogram. When I say the variation is this one. Okay, so how many of them, even though you see this histogram, okay, it is actually depends on the height. Right now I use each block is one, so I can count it and understood. Yeah, but for this you have no idea what's the height. Yeah, it's showing you with the hidden coded, yeah, height, which is 0.025 here. So you have an issue how to decipher to end up getting 36 right here. Yeah, and that's another issue, I believe. So since you cannot be able to get easily that 36 out of this graph, you have an issue trying to calculate the probability, because you need this number to calculate. You also need this, okay, how many times they show up, which is based on this guy, yeah. And so you have no way out but to come up, understanding of that if you truly want to get, the probability of it. Because if the person, whoever, composed the histogram didn't reveal the height, it would be very difficult for you. Right now I reveal the height because I go with the equal, yeah. So this is 1, and then this is 2, 3, and then 4. Of course, I counted like 6 is 6 is this one. I supposed to actually there is a this needs to be actually only 5. Yeah, so you have a 1, 2, and then this is 3, and that's 4, and that's 5, and of course this is supposed to go to here. Yeah, so there's a 1. We have a cutoff here that I need to fix. That's because when I inserted this column, yeah, to put the probability percent, I forget to put this back. So anyways, right now I know the height, yeah. So since I know the height for getting 7, I know the total 36 because all I do is I count them. So this is, like I draw my cell by giving each one of them is 1. So that's a 1. So I know that this is going to be 2. Yeah, this is so if you count it, you're going to get 36. So 1, and then 2, yeah, and then 3, okay, and then 4, 5, 6. We do the same thing. 7, 8, 9, 10. Okay, so if you count all the way to here, you're going to get 36 cells. Yeah, so that's another thing. Without calculating, you can just count it. So 7, we know that there are 6 of them, yeah, by counting this cell. So 1, 2, 3, 4, 5, 6. So 6 out of 36. So all of this blue area is together 36. So here, if you count it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, okay, 12, 13, 14, 15, 16, 17, 18, 19, 20, okay, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, and 36. See, so 36, so 7 out of 36 is 16.67. So that's visual, yeah. But again, your graph got to be systematically drawn. here you have an issue. You know that this is the highest probability, but in order for you to tell exactly what is the number 16.67, you need, okay, you need the specification of this area. Otherwise, it will be very difficult for you to calculate out of the graph. Yeah. So this graph, it is given you, but it is given you with a very coded, which is like going 0.025 for each one of them. So you're gonna have to play with this number in order for you to get, if you want to use this graph, yeah, to calculate the percentage out of it. So anyway, for 3 dice, again, if I were you, I am drawing like this for each one of them. So I can be, so your homework is do, 3 dice. I have already done 4 dice here for you, okay? So all you have to do is attempt to do the 3 dice in the way that I just show it to you. So that's your homework, and do your that, and you should be able to tell me exactly, okay, which one. So you know that 10, by eyeballing here, we definitely know 10 and 11 has the highest probability, yeah. And how much is that probability? You need the height. You can go with each height is a 1 unit, like I did, okay, pretty easy. And if you don't want to do it, you can also do it in the way you want to do it, okay. So anyway, so equal distribution and bell shape. Here bell shape, and then here your bell shape, okay. All right, so that's done with your rolling the dice. Okay, so now you now understand in most of the textbook, yeah, you're gonna come across kind of like this. Well, this is a textbook slide. So anyway, so because most of the processes we measure are actually the sum of many smaller processes, the overwhelming majority of the natural processes will have a typical bell-shaped curve. You understand this very well now, yeah? So bell-shaped curve, also called the normal distribution. So we show you, yeah, example like this. Okay, and here is your bell-shaped curve. Your smaller process, this is your small process 1, small process 2. Okay, the small process 3 is the sum of your smaller process, because we add this and this, right? 1 plus 1 is 2. Okay, and then of course the corresponding probability right here, calculating mathematically and calculating visually with the histogram and the curve, yeah. And this is your normal curve. So anyway, so that's what it is talking about. If you're just reading this thing like 1,000 times, you're not going to get it, okay. And you definitely need to draw like this, okay. I'll give you the homework for the 3 dice, yeah. I have already shown you 4 dice here, and then of course 2 dice here. So you should be able to come up with your 3 dice, this guy, yeah, at your home, yeah. Draw that on your Excel and do exactly the same as I'm doing, and you should be able to see and understand what it meant by actually the sum of many smaller processes, okay. And then what is meant by your bell-shaped curve and your normal distribution, okay. Okay, so every time we deal with a new process for the very first time, so what we typically do is we will create a histogram, okay, just the one that I just showed it to you, like that. We're going to create a histogram to see the shape of the histogram, yeah. So if you look at the histogram, I know that this is a totally bell, yeah, and also this is also bell, but this one is a little bit different on the tail side, because you have only two ones here and 1 2 here, and we have 3, okay, 2 here, and 1 2 3 4 here, so the tail is longer on that side, yeah. So anyway, so that's how we check the shape of the histogram. Of course, once you get everything by heart, so now I get, if I say like 2 dice, my brain automatically understand 11 and 36. Okay, 4 dice, I know 21 and 47, yeah, without even looking at it. This is just a redundancy of the combination. But if you come down to filtering the repeated, yeah, these are all repeated stuff, and then you're gonna have a 21 and 47 anyway. So yeah, so therefore 3 divided by 47 is going to give you probability. Of course, you can do something like this here. So anyway, so for the first time you got to do it, so that way you can be able to learn and it's in your head. And so when you encounter something like this, you can say very, very easily, yes, getting a 7 is a 16.67 for 2 dice, right away. So anyway, so once we establish that it is a normal distribution, then we can use the formulas for the normal distribution for analysis of that data set, So if it is a different shape, then we have to figure out why, and then we have to figure out which mathematical function is the best fit for predicting, okay, that particular process. So we can apply either Weibo or exponent, okay, distribution, or chi-square or f distribution, so and so, yeah, beta gamma. So because so many processes exhibit the normal distribution, that this is our normal curve, because many processes, the data we don't know why usually give you this normal distribution, the bell-shaped curve. So that's the model that we learn first and spend most of our time, on it. So anyway, this is what you need to do for understanding, okay, rolling of the dice, okay, especially that is for the part number 2, okay. So if you want, I can do the probability percent, okay, for this guy, yeah, you can actually do the same as we did as always. So probability, yeah. We will do exactly the same as what I just show you here, and of course that is always in percent, and we can go like that, okay. And of course we're gonna choose this. Before that, I always forget my bracket. Divided by, we're gonna divide with this, okay, and you can lock it. So one change. And then multiply with 100, okay. And of course, we just want to give a 2 decimal is fine for us. So make sure you review your Excel, okay. Do that, please. Well, then just drag it, okay. And these are the probability, and you see that, 14 is 6.38. Of course, you always check your probability. You gotta add to 100. Yeah. This is what I always do. Yes. So when we study all the way to PhD, we're trained to do this, automatically. So anyways, what we do here is we always check if our probability calculation is right or wrong by summing it up and see if we're getting 100. If you don't get 100 here, and you're doing something wrong, so I'm just gonna highlight that for you. So this is how we check the calculation. Yes. So anyway, so I will, yes, if you want this Excel, I will give you that. Yes, make sure that you use it and study. This is for your part 1, and this is of course for your part 2. Yeah, and we will go into part 3. Yeah, it takes a long time for us to because I don't want to go over 1 hour ish, lecture. So I'm thinking to divide it. Let me see what is the next section for that. So the next section is the mean and the standard deviation. So I can start this a little bit for you. So a mean is really easy for you to find it. And I've already shown you several lectures on mean and standard deviation. I've already given you the extra template for review. And if you are using the same process every day, and your data histogram is going to give you the bell-shaped normal distribution, then you don't have to draw it again and again every day. You only have to do it because you're doing the same process anyway. So you can just measure the parts and then calculate the mean and average right away. And then of course followed by your standard deviation, and you're going to visualize that curve that very closely approximate what the histogram is going to look like. So you don't really need to draw this histogram again and again. You draw the histogram only one time, and then we can jump straight into the finding the mean, meaning like we can just do the curve directly without doing the histogram. So instead of doing the histogram, since we're using the same process every day, we can find the mean, standard deviation, and all other stuff that we need, okay, in our normal distribution. So every time we draw the mean and the standard deviation, it's better that we draw our normal distribution curve, so that way you can be able to see or visualize your mean and the standard deviation, your data point far away from your mean. So for example, if we measure all parts in the histogram below, we will calculate the mean. In this example, the mean is around 51.4. So if you eyeball it, it's around here. So if you calculate it, you got 51.4 millimeter, and your standard deviation after you calculate, you got 0.2 millimeter for this data set. So then we wouldn't actually draw the histogram, but instead we would visualize a normal distribution curve on this side. So you wouldn't actually draw the curve on the right. We would just say the mean length of the part is 51.4, because it's already calculated here. That's your mean. And then of course this little mean symbol is telling you you're dealing with a sample. And then of course we can use the sample data to predict the population later. And of course this is your standard deviation is 0.2 millimeter for this example. So the mean length of the part is 51.4 millimeter. And then standard deviation, of the parts is going to be 0.2 millimeter. Alright, so after we know the mean and the standard deviation, we can do predictions. So we can predict how the products or process are distributed just by looking at the graph that we just drew. Okay, so distribute in terms of the size, the weight, or whatever that we want to find out. So we know the mean is 51.4 millimeter, the standard deviation is 0.2 millimeter for our data sets right there. So we can say about, when you look at it, from here to here, 34.1, on this side 34.1. So in total of this area, when we say the percentage, we're talking about this highlighted blue area, and that area is 68.2% out of the entire area, which is a little light blue. There's a variation of a blue color here, so lightest and lighter, and then the darkest blue. All of the area. So this area over 100 is going to give you 68.2% is this area, and that is going to be within the when you look at it, that is going to be within plus is up and the minus is down, 1 standard deviation from the mean. So 2 standard deviation is going to cover all the way from here and to here. So all you have to do is just add 13.6 to 68.2, another 13.6 to there. So in total you're going to get so I'm just going to calculate that for you here. So you have, what is it, 68 point or something, I forget, 68.4 I believe. So you have 68.2 and 13.6, 68.2 and then 13.6. And you have 2 sides, so altogether you're going to have a 95.4 percent. That is the mean standard deviation. This is, I would just say, area, and this is your normal distribution. Normal distribution mean. That's what we're trying to do. Alright, calculating mean and the standard deviation. So don't forget the sample. We're on the sample. So anyway, so 95.4 percent from here all the way to here, and 68.2% is your first standard deviation. I'm just going to write area here. So 68.2%, and that is within the first sigma GMA, and this is within the 2 sigmas, right? In 1 sigma, this is 2 sigma is 95, and then of course your 3 sigma is going to include another 2.1%. So another 2.1%. If you add it. So all you have to do is add this guy, and then plus 2.1% 2 times. So you look at for 3 sigmas, you're gonna get 99.6% of the parts are in there. Yeah. So that's how we calculate the sigma, the standard deviation. Okay. So from here to here is a 99.6. From here to here is 95.4, and then from here to here is a 68.2. Okay, you have 1 standard deviation, 2 standard deviations, and the 3 standard deviation. I call it sigma as the same thing. Yeah, so I should write this down for you. That's a 1 standard deviation. This is a 2 standard deviation, and don't forget going plus and minus. Okay. So I am gonna write a plus and minus here, and then of course this is a 3. We don't need that. I'm just gonna write it as a. I hate this. So anyways, plus and minus. Okay, plus minus. So that way you understand. We're talking about both sides. Yeah. Standard deviations. Of course, we for 6 sigma term, we call it 1 sigma, 2 sigma, and 3 sigma. It's the same thing. For prediction of the product, you can look at the area. So we know if we concentrate here, 13.6% of the product, okay, is going to be 51 to 51.2, yeah, millimeters. From here to here, 68.2%, 51.2 to 51.6 millimeter your parts are. Yeah. So that's how we read, okay, and use a mean standard deviation and play with the parts. In this case, we're looking at the parts, yeah, in your process. So that's pretty much how we use it. Okay. So let me stop the part 2 here. And we're gonna go into part 3. Yeah. All right. Make sure you do your the 3 dice rolling. Okay. Problem all by yourself in your Excel, please. So I'm gonna go ahead and stop the part 2 right here, and take a little break and come back here and I'll give you part 4.